The other schema design principle you will learn about is known as the principle of least cardinality. This principle provides you a guideline for how to resolve one-to-many and many-to-many relationships with MongoDB. MongoDB documents can contain arrays. There's nothing to stop you from including every single review a user posts in the user document. Depending on your use case, that may be a decent idea. But beware, arrays that grow without bound are a very bad MongoDB anti-pattern. If you can't limit the number of reviews a user can post, your document size will become massive. This is bad for MongoDB performance, this is bad because of MongoDB's 16 megabyte document size limit, and bad because it wastes network throughput. As a web developer, you should defend your network throughput from unnecessary data, because network throughput will most always be your scarcest resource. The ideal schema design, in the case of an unbounded number of reviews, would be for reviews to track which user posted them, rather than listing out the reviews in the user document. This is an instance of the principle of least cardinality. Tracking the user in the review document results in smaller array sizes than tracking the review documents in the user document. This is because in this schema, a review is posted by exactly one user, but a user can post an unlimited number of reviews. This principle can also be applied to many-to-many relationships. Suppose you were to design a MongoDB schema for a site like meetup.com, where users register for events with a capped number of attendees. In SQL, the schema design would be easy. You would have a mapping table for users and events. This table would store rows that contain a user ID and an event ID. In MongoDB, the solution is not quite as cut and dried. If you expect users to attend numerous events and events to have millions of attendees, a mapping collection analogous to an SQL mapping table would likely be the right choice. However, if you assume that each event will only have at most a few hundred attendees, you can denormalize this many-to-many relationship by keeping a list of IDs representing attendees in the event document itself. This is because you assume that the number of attendees for any given event is never going to grow without bound and will be at most a couple hundred. Don't take the number 500 for argument's sake as gospel. The right MongoDB schema design always depends on the store what you query for principle. But always remember, arrays that grow without bound are always a bad choice in MongoDB.